Periodic Table Part 2. In Part 1, we covered the general trends in the periodic table, such as metallic character, and we looked at the alkali metals that are in Group 1. Go back and watch that video if you haven't seen it yet. This is a Part 2. So when we were looking at the table last time, the groups and the trends, I skipped over this section here, in the middle between Groups 2 and Group 3. This section of elements is quite a large section. It contains a lot of elements, but this section is put here because they all have properties in common, but they don't have trends in the same way that the elements in the groups do. These elements are called the transition elements. They're also known as the transition metals because they're all metals. In here are some metals you've definitely heard of, so iron, copper, gold. There's also some that you may not have heard of, osmium, tantalum. The transition metals all have the properties of typical metals. They are strong, malleable, shiny, they're good conductors of heat and electricity. A common question is to ask you to compare their properties to the metals in Group 1 that we looked at last time. We can do this with physical or chemical properties. Physical property differences, is that they are denser than Group 1 and they have higher melting and boiling points than Group 1, with the exception of mercury, which has a low melting point. The transition metals all have some chemical properties in common too, which are different to the Group 1 metals. So the chemical properties of the transition metals, they are a lot less reactive than the Group 1 metals, although there is a range of reactivities within the transition elements. Some are very reactive, some are unreactive, but they're all less reactive than Group 1. Some other characteristic properties of this group is that they form colored compounds. Their compounds are colorful. Take note, be really careful. It's wrong to say that the elements themselves are colored. They aren't. They're usually gray. But the compounds they form are brightly colored. For example, copper compounds are blue or green. You can also make red and purple and yellow, all these different colors. But the elements themselves are not colored. Be really careful on that. Transition metals are excellent catalysts. They are often used in chemical reactions to catalyze a reaction, make it happen more quickly at a lower energy. Transition metals also have variable oxidation states, and what that means is they form more than one type of ion. For example, iron, Fe, can form +2 or +3 ions, so it can have an oxidation state of +2 or +3. So that's a transition element, a very important block in the periodic table with their own properties, but not in one of the numbered groups. Let's go over to the other side of the periodic table now and look at Group 7. Here it is: fluorine, chlorine, bromine, iodine. This group also has a name. The elements in this group are called the halogens. Some properties of the halogens: they are all toxic elements. They're all quite reactive, and they're all colored. This time the actual elements themselves are colored. You have to know the colors of these elements. So fluorine is a very, very light pale yellow. Chlorine is a pale green. Bromine is brown. Iodine is gray when it's a solid, brown when it is in solution, and purple when it is a vapor. Something else they all have in common is that they are diatomic elements. That means that they hang around in pairs. They form molecules of the type F2, Cl2, Br2, I2. That's really important to remember when you're making equations and half equations and trying to balance things. When they make ions, they all have a -1 charge. That's because they gain 1 electron to fill their outer shells. The halogens also have noticeable trends in their properties when you go down the group. Firstly, their melting and boiling point increases. This means that going down, they melt and they boil at higher temperatures. So at room temperature, fluorine and chlorine are gases, bromine is a liquid, and iodine is a solid at room temperature. The next trend, and probably the most important one, when you go down Group 7, is their reactivity. They actually get less reactive going down the group. So fluorine is the most reactive one in the group, chlorine is less reactive than fluorine, bromine is less reactive than chlorine, iodine is less reactive than bromine. Notice that this is the other way around from Group 1. Group 1, the reactivity increases down the group. Group 7, the reactivity decreases down the group. Don't get them confused. Using these trends, you can predict the properties of astatine, the other element in group 7. It is at the bottom there. It follows the pattern, so it will form -1 ions. It will be diatomic. It will be dark colored. It will be a solid at room temperature, and it will be less reactive than iodine or any of the others in the group. So that's the halogens. There's one final group to take a look at, and that's group 8, sometimes called group 0. These elements are helium, neon, argon, krypton, xenon, and radon. They're known as the noble gases. The noble gases are all gases at room temperature. They're all monoatomic. That means they don't form pairs, they exist as single atoms. And most importantly, they are all very unreactive. Another word for unreactive is inert. This is because they already have a full outer shell of electrons. They get heavier as you go down the group, but that's the only real trend in this group. They don't really do much in terms of reactions. They're used whenever an unreactive atmosphere is needed, such as for welding. Alright, that covers the trends you need to know in the periodic table. Thanks for watching.